my channel. This is the last video of this chapter, that is acid, bases and salt. So today we will finish this chapter by this last video. So in this video we will discuss about some of the important things of salt. So first of all we will start the video from the preparation of salts, means how the salts can be prepared. There are various methods are there by which we can prepare the salts. So first of all we will discuss about the first method, that is combining of two elements, means how we can combine the two elements and can prepare the salt. So suppose we are taking Na, sodium plus chlorine. These are the two elements. Sodium is one element, chlorine is one element, and we are getting 2 NaCl. So this is a salt. This is a salt. So here the salt is obtained by combining two elements. Okay. So another example, if we will take Fe plus Cl2. So two elements Fe and Cl2, when they are combined they are giving FeCl3. FeCl3. So this is another salt. So here this FeCl3 salt is obtained by the reaction of this iron element and the chlorine element. Next, the second method, the action of metal with dilute acid. Action of metal with dilute acid. How can we prepare the salt? By treating the heavy metal with dilute acid. For example, suppose we are taking the zinc and we are taking the dilute H2SO4. So what happened in this case? It will give zinc sulfate plus hydrogen gas as a byproduct. So here the zinc sulfate is the salt which is prepared by the action of dilute H2SO4 on heavy metal. So zinc displaces the hydrogen and forms the zinc sulfate, which is a salt. So here the salt is obtained by treating the metal with the dilute acid. So and we are getting the salt and hydrogen as a byproduct. Second is the decomposition method. Means what happened? We are taking some salt like bicarbonate, carbonate, chloride, nitrate. These are some of the salt we will take, and then we can decompose into some simpler salts. We will decompose into some simpler salts. For example, if we take the sodium hydrogen carbonate, NaHCO3, when it is treated with the HCl, what happened? We are getting Na2 NaCl, we are getting NaCl, this is the salt, plus water plus carbon dioxide, So whenever the bicarbonates are treated with the acid, we are getting the salt plus water and carbon dioxide as a byproduct. So by treating the bicarbonate with HCl, we are getting the salt, that is salt NaCl, and we are getting the byproduct H2O and CO2. Similarly, if we will also take the carbonate, for example Na2CO3, sodium carbonate, also when treated with the HCl, they are giving same product, that is NaCl plus H2O plus CO2. So here what happened? The metal atom replaces the hydrogen. The metal atom replaces the hydrogen and forms the salt, which I have already discussed in the previous chapter. Whenever the metal atom is replacing the hydrogen from the acid, then they are giving the salt. So by decomposition of bicarbonate and carbonate, we can get the salt. Similarly, if we will take the case of chloride, for example, we are taking the NaCl. We are taking NaCl. If we are treating with the H2SO4 and the temperature is below 200 degree Celsius, 200 degrees Celsius, when the NaCl is treated with H2SO4, what happened? Chloride is there. So what we are getting? We are getting NaHSO4. Okay, and HCl as a byproduct. So this is another salt. From one salt, by treating with acid, we are getting another salt, that is NaHSO4 plus HCl. Similarly, if nitrate, KNO3 is there, and we are treating with the sulfuric acid, H2SO4, same reaction, and the condition is same below 200 degrees centigrade. 200 degrees centigrade. Here also the product we will get, that is KHSO4 plus HNO3 So here also we are getting the salt, that is KHSO4 plus HNO3 as a byproduct. So these two are the salts obtained by the salt treating with the acid, which decompose into some simpler salts, So now we will come to the fourth method, that is the neutralization method. Already you know that whenever the acids treated with bases, HCl treated with bases, NaOH, HCl treated with the NaOH, what happened? They are giving salt plus water as a byproduct. So already we have discussed in the neutralization reaction, acid and bases reacts to give salt plus water. So now come to the last method for the preparation of the salt by using alkalis. Alkalis means, for example, NaOH. Okay. So whenever they are treated with some of the metals like zinc, heavy metals, we are using zinc, aluminum, this type of metals are there. When they are treated with the bases, alkalis, they are giving a complex salt, that is Na2ZnO2, and these are called as the complex salt. And here also the byproduct will be hydrogen gas. Clear? Similarly, another example, if this NaOH is treated with aluminium, here also we are getting one complex salt, that is NaAlO2 plus H2. So this is called as the sodium aluminate. And this is called as the sodium jincate. And this is called as sodium aluminate. Clear? So here we are getting two complex salt by treating the metal with the alkalis. So these are few of the examples of preparation of salt. Means by this method we can prepare the different types of salts. Clear? By this method we can prepare the different kinds of salts, and basically we will follow this 5 method for the preparation. So important compounds, means generally sodium chloride is an important salt from which we can prepare many types of compound which we are using in our day-to-day life. So here the important thing is that what are the compounds we are obtained from the most important salt, that is sodium chloride, means NaCl. From the NaCl, what are the compounds we are getting? Now we are going to discuss that now. So first of all is the caustic soda, whose formula is NaOH, so which is also known as sodium hydroxide. So what happened? How we can prepare this caustic soda or the sodium hydroxide? So NaCl, when dissolved in water, this is called as brine solution. So whenever the brine solution is passed with electricity, they will decompose into sodium hydroxide, chlorine gas and hydrogen gas. So chlorine gas and hydrogen gas are collected separately and can be used for further important chemical reactions, but here we are getting the caustic soda. So how the caustic soda or the sodium hydroxide can be prepared? By treating the brine solution, by passing electricity through the brine solution. What is brine solution? Solution of NaCl in water. So when the electricity is passed through brine solution, we are getting the caustic soda, and as a byproduct we are getting chlorine and the hydrogen gas. So what are the uses of this caustic soda? This is mainly used in the soap preparation. Similarly, second important compound is the bleaching powder. Bleaching powder, which having the formula CaOCl2, which is also known as calcium oxychloride. Calcium oxychloride. Clear? So, when the calcium hydroxide is treated with the chlorine gas obtained in the first method, when it is treated with the calcium hydroxide, it gives calcium oxychloride, whose commercial name is bleaching powder. And here we will get the byproduct hydrogen gas again. So what is the use of this bleaching powder? It is mainly used for the disinfection of toilets. Means mainly to clean the toilets and bathrooms we are using this bleaching powder, because this will work like an disinfectant. What are the other uses of bleaching powder? It is also used for the purification of water. Next, we will go to the third one. Third one is called as the baking soda. Baking soda, whose chemical formula is NaHCO3. Which is also called as sodium bicarbonate. So when the brine solution is passed with ammonia and carbon dioxide, NH3 is the ammonia and CO2 carbon dioxide. When brine solution, means the solution of NaCl in water, is passed through ammonia and carbon dioxide, it gives ammonium chloride and it gives the sodium bicarbonate. So this is the preparation method of sodium bicarbonate. So here, what is the use of this sodium bicarbonate? Sodium bicarbonate is mainly used in bakery industry. To make the bakery items soft. But we are not directly using the baking soda. Because baking soda is basic in nature. That's why we are not directly using the baking soda. So what we are using, we are adding tartaric acid. So when the tartaric acid is added, the basic nature of the baking soda will get neutralized. Because this is base, this is acid. So when we are adding tartaric acid in baking soda, the bitterness of the baking soda will goes away. Why? Because the tartaric acid neutralizes the baking soda. So when it neutralizes the baking soda, what happens? We are not feeling bitter taste, and that is called as the baking powder. These two combinedly are called as baking powder. So this is the difference between baking soda and baking powder. Baking soda is alkaline in nature, but when we are adding tartaric acid, they are giving baking powder. Clear? So what is the uses? It is mainly used in bakery industry to make the bakery items soft. What are other uses? It can be used in antacid. It can be used in fire extinguishers. So this baking soda is also used as an antacid, also used in the fire extinguishers. Next, the fourth is the washing soda, which we obtain from the baking soda. So what is washing soda or washing powder? Washing powder is sodium carbonate decahydrate, 10 molecules of H2O. This is called as water of crystallization. WOC, water of crystallization. So whenever any ionic compound is dissolved with excess quantity, at that time what happened? Suddenly by cooling, they will crystal out with some water molecule. They suddenly crystallizes with some water molecule, and this is the water of crystallization. Means it possesses 10 molecules of water. And the crystal of sodium carbonate possesses 10 molecules of water, that is called as water of crystallization. So first of all, this sodium bicarbonate, when heated, they give sodium carbonate. So when this sodium carbonate is mixed with water or crystallizes with water, they crystallizes out by Na2CO3.10H2O. means the sodium carbonate crystallizes out by 10 molecules of water, and this is the formula of washing soda. So now what is the uses? Washing soda is used mainly in laundry to cleaning the clothes. And what are the other uses? It is also used to remove the hardness from water. It is also used to remove the hardness from water. So this is the fourth compound, and the last compound, the important compound, is the plaster of Paris. Plaster of Paris, whose formula is calcium sulfate hemihydrate. Calcium sulfate hemihydrate. So calcium sulfate hemihydrate means half molecules, half of the water molecule. So when the gypsum, that is calcium sulfate dot 2H2, that is the gypsum is heated below 373 Kelvin temperature, 393 Kelvin temperature. When it is heated below 393 Kelvin temperature, they are giving calcium sulfate hemihydrate. Calcium sulfate hemihydrate, which is called as what? Plaster of Paris. So what is the uses of plaster of Paris? Generally we know that plaster of Paris can be used to plaster the broken bones, to join the fractured bones. To join the fractured bones, we are using the plaster of Paris. And plaster of Paris can also be used in making statues and models. So this is all about the compounds obtained from the NaCl. These are some of the compounds, their uses in our day-to-day life, which are obtained from the NaCl. So in this way, this chapter is over. We have discussed all the aspects of acid, bases and salt. Thank you and have a